Hello and welcome to Database Topic Lesson 2. As you can see from the slide, we're going to cover a number of topics. I'm going to give you a few moments to look at the list before we move on. On this slide, you can see an example of a data dictionary, which is typically created on a spreadsheet. A data dictionary will describe every detail of the database, such as how the records are organized and their purpose. So for every field in your tables, there is information saying what type of data they are going to have, how long you expect the text to be, what type of data or what data type you can expect in the data itself, like number, is all kept on a data dictionary. In this example, we see the table or entities that would be stored in the database. You can see that we have a contacts and an address entity. In the column, you can see the names of the fields. But since we're dealing with a relational database, we call these fields attributes. So contact ID, first name and last name, etc. are all attributes. The data types are shown. We have integer, fields which can hold up to 100 characters, and fields which will hold only one character. The data dictionary will show which fields are the primary key and which fields can be left empty or otherwise called null. In the description column, we have descriptions for each of the attribute names to give them a little more meaning. Under marital stat, we see that only certain letters are going to be allowed. This will mean that when the database is created, a validation rule will need to be created for this attribute to ensure that only one of these letters can be entered. All of this data is in this data dictionary is called metadata. It is data about data, and it helps to ensure that as fewer mistakes are going to be made when creating this database. So having high data integrity, meaning we will have a database that is efficient and holding reliable information. In the last slide, we touched on the idea of validation rules. Validation is about making sure that the data entered is sensible, possible, and within reasonable bounds. Validation rules will also make sure that data entered into the database is consistently formatted correctly. It is important to note that a limitation of validation is that it will check if a value is reasonable and possible, but that does not mean that the value entered is actually correct. So a pupil's date of birth may pass the validation checks in that it is a sensible date and be formatted correctly, but the pupil's entered date of birth could be wrong. There are several different validation tests. A data check uses an input mask to enter the date a certain way, such as with 2 Ds, forward stroke, 2 Ms, forward stroke, and 4 Ys. A range check ensures that a value is within a predetermined range, i.e. between 1 and 12. A field length check makes sure the postcode or phone number has the correct number of characters. A field presence check ensures that all necessary fields have been filled in. A type check checks the type of data being put into a computer function to ensure words are not being multiplied or added against numbers. It is also used to check the @ sign in an email address or that a date has been entered correctly. Other means of ensuring data is entered correctly is with the use of a drop-down menu, which limits the user's choice and forces the correct spelling to be inputted. An example could be product availability list, or by using domain integrity or referential integrity. We will look at these two terms shortly. Over the next few slides, we're going to be looking at more database terminology. It is important that you know all of these, as there is always a question on one of these terms. Let's start with data structure. This is how the data is stored and organized. So in a database, the data structure will be made up of files, records, tables, and fields. Whatever the data structure, it needs to be set up to meet the required purpose, and that people who access this database can do it properly and efficiently. Data definition determines how the data will be shown. So a data's data type, its size and formatting, the description of the field, the validation rules and constraints placed upon the data, and whether a primary key has been allocated to the data will define that data. In short, what defines the database will be those tables, data types, size and formatting, description, validation rules, constraint, and primary and foreign keys. What you do not want in a relational database is data redundancy. Data redundancy is a condition created by data duplication within a database or data storage area in which the same piece of data is held in two separate places. This could be where the data is in two different fields in the database table, or that the same data is stored in two different locations. So in a large university, a student's name, student identification number, and address could be stored with different departments. Data redundancy can be costly due to increased storage and cause processing of the data to be slowed, so making the whole system inefficient and open to the possibility of having corrupted data. The hallmark of an efficient database is that data should be entered just once. Normalization is a process we will look at in a later lesson, but it is used to get rid of data redundancy. Data duplication is when an exact copy of a piece of data is created. This creates, as we have seen, data redundancy within a database. Data can appear multiple times in a database for a variety of reasons. For example, a shop may have the same customer's name appearing several times if that customer has bought several different products at different dates. Data duplication is not always a bad thing. It's beneficial and intentional when providing backup copies of files and creating multiple versions of a file. Data integrity is the process of ensuring that data is accurate, consistent, valid, and reliable for the duration of that data being in the database. Problems with data integrity occur when there is data duplication and data redundancy. If changes occur to data which is duplicated, then all duplicated data must be updated or errors will occur and data integrity is lost. Data integrity is fundamental to making or breaking an IT system. Relational databases will usually have several tables. These tables are linked by using a primary and foreign key, as you can see in this slide. Referential integrity makes sure that this link this relationship remains consistent. Consistent means that the data contained in the foreign key field cannot be changed in any way, i.e. added, deleted or altered, unless those changes have already been made in the primary key. Having referential integrity means that null values are not created accidentally, and that both the primary key field and foreign key field will have the same data types. As you may recall, we talked about domain integrity in Lesson 1. Since we are talking about various forms of integrity, it would be apt to mention this again. Domain integrity puts constraints or boundaries on what data can be entered into a specific field and how that data should be formatted. Such constraints could be the field length of data allowed, or data type used, or what specific word or letter can be used. For example, within a gender field, the domain rule could be that only M or F, not male or female, can be entered. By having domain integrity, it gives the database a high level of organization and validity within the database structure. Domain integrity is useful when you want staff members to input data efficiently and accurately, whether it be into a field, in a table, or into a form. By having domain integrity, staff members can enter data as how the company want it entered, and making sure that data is not inputted in the wrong place. Entity integrity ensures that the primary key is valid and that every table in the database has the following properties. A primary key field that is unique for each entity. The primary key must not be null, i.e. contain a value of some sort. No records contain null entries. No duplicate records within the table. Fields that identify each record within the table is unique. All of the above prevents record duplication and data anomalies. In the previous slide, we touched on the term data anomalies. An anomaly is something unusual, unexpected, an abnormality. Anomalies can occur in poorly planned, unnormalized databases where all the data is stored in one table like a flat file database. There are three types of data anomalies: update, insert, and delete. An update anomaly occurs in databases which have not been normalized. We will look at normalization in a later lesson. An update anomaly is when data has been partially updated within the database, but not all instances have been manually updated. The reason why these updates have not been done automatically is that this data has not been put in one place that is consolidated or referenced. We can say linked to other parts of the database. Update anomalies create inconsistencies in the data and reduce data integrity. In the example, you can see the data about John Smith is repeated because he can drive one of several cars. If John Smith changes his email address, all three occurrences would need to be updated to ensure that the data remains accurate. Otherwise, we will have an update anomaly. An insert anomaly occurs in an unnormalized database. There are two types of insert anomaly. Firstly, when data is added to the table and there are gaps in the record, as in the case of Sam Spade. Here we have several null fields. A second instance of an insert anomaly is when the same data is added to the table, causing data duplication, as in the case of John Smith. By adding the data more than once, this insert anomaly can create the possibility of an update anomaly when updates on the data are required. A delete anomaly can again be found in databases that have not been normalized. A deletion anomaly can occur when a record is deleted within a database and data contained within that record is only found in that record. As a result, data is unintentionally lost due to the deletion of other data. For example, if the second row is deleted because John Smith sells the car with registration 1QAZ889, then the website for Ford, that's www.ford.com.au, is also lost as this data only occurs in that record. Manipulating data is that process of resorting, such as sorting on a different field in either ascending or descending order. It can also be rearranging, which could be moving fields in a table or query to a different position within that table or query, or otherwise simply moving data without fundamentally changing it. This manipulation involves inserting data into database tables, such as adding records to an existing table, retrieving existing data, deleting data from existing tables, such as removing records from a table, modifying existing data either individually or in bulk by using an update query. You will become familiar with update queries as you work through your practical work booklet. Data security was touched on when discussing centralized databases. Data security is all about taking measures to protect the data from unauthorized access, both physically and electronically. Data security is also about preventing the data from being corrupted. To ensure data security, there are a number of security methods which are shown on this slide. You should remember at least 5 of these. So we have passwords, 6 characters long as a minimum, no possible personal identifiers or attributes such as date of birth, use of upper, lower cases, numerals and symbols should be used. Encryption, access levels, databases kept on separate servers, backups with one of the backups stored off-site, secure doors with locks and grilled windows around the hardware that the database is stored on, usernames combined with passwords or even biometric access, installing antivirus and firewalls, both physical and virtual, and encrypting of the data when it's backed up as well. As we have seen from the previous slide, one method of data security is encryption. We will look at encryption in more detail in the network topic, but here we will give a definition of what encryption is. Encryption, also called ciphertext, is the process of transforming messages or data to protect the meaning. Encryption scrambles a message so that it is meaningful only to the person who encrypted the message and to the person holding the key to deciphering it. To everyone else, it is gobbledygook. The reverse process, decryption, converts a seemingly senseless character string into the original message. On this slide, you see an example of a message that has been encrypted. This concludes our lesson 2. As you will have done with lesson 1 questions, use the same method for the questions related to lesson 2. Answer the questions which will be in Sector and in Dropbox with your database booklet. Next day, answer them again without using your database booklet. Anything you have forgotten, create memory cards or mind maps or diagrams to help you remember the material. In our next video, we will explore the process of normalization, turning an inefficient and error-prone database into one which is efficient and has high data integrity. Thank you for watching. Goodbye.